Hello everybody. Today we are going to be learning about how to factor a monomial from a polynomial. And if you remember from the last video, we learned that mon means one and poly means many. So what we are going to be doing is learning how to factor something that has one term from something that has many terms. But before we do that, let's take a look at the first topic, which is what are factors? Factoring is really the reverse of multiplication. So to factor an expression means to list out all of the numbers that multiply together to make it. So for example, if I were going to say, and I'm going to do this as an example, list all the factors of, let's do 30. Let's do 30. List all the factors of 30. What I would do is I would list all of the factors that you can multiply together to make 30. So some obvious ones come to mind, like 2 and 15. Or 10 and 3, because 10 times 3 is 30. Or 30 and 1, because 30 times 1 is 30. And I'm missing one. Obviously, we could do 6 and 5, because 6 times 5 is 30. But we also need to remember that when you multiply two negatives together, they make a positive. So we can do minus 2 and minus 15. Minus 2 times minus 15 is 30. We can do minus 10 and minus 3. That's 30. We can do minus 30 and minus 1. That equals positive 30. And then we can also do minus 6, minus 5. That also equals positive 30. So remember, to factor an expression means to list out all of the numbers that multiply together to make it. So the next topic I want to talk about is determining what's called the greatest common factor. So we're not just looking at any factors, we're looking at the greatest common, which is like shared factor. And so the GCF, we call it the GCF a lot of times instead of greatest common factor. The GCF is the biggest number or term that goes into all of the numbers that we're working with. So how do we find the GCF? Because when we get back to this main topic, factoring a monomial from a polynomial, this idea of the GCF is going to be really important. So how do we do it? There's 3 steps, and I'll list them as step A, B, and C. So step A, you're going to write each number as a product of its primes. Write each number as a product of its primes. And remember, a prime number is a number that can only be divided by itself and by 1. Okay, so step 2 is you're going to figure out which primes are common to either both of the numbers you're working with, if you're working with 2, or to all of the numbers you're working with, if you're working with more than 2. And step 3 is you're going to multiply the common primes together. Multiply the common primes together. Okay, this is definitely going to make more sense when we look at an example. So let's do that. And I want to find the GCF of, and I'm going to look at two numbers, 48 and 60. Okay, so how do I do this? Step A, write each number as a product of its primes. So here's how we do it. Let's first start with 48. Ah, that is an ugly 8. That's okay, we're going to fix them. You write 48, and then we're going to make a little tree. And we're going to think of numbers that we can multiply together to equal 48. So one that's popping in my head is 4 and 12. You're going to think, can I think of any factors that go into 4? I definitely can. I can think of 2 and 2. And 12, I can think of 6 and 2. And I know I can't break down a 2, it's a prime number, but I can break down a 6 into a 2 and a 3. So the factors of 48 are 2, the prime factors are 2, 2, 2, 3, and 2. So now let's do 60. And I'm going to break it down, and I'm going to do 10 and 6 because those are the first two numbers that popped into my head that multiply to 60. And I can break down a 10 into a 2 and a 5. Those are both prime numbers, so I'm going to stop. And I can break down a 6 into a 2 and a 3. Those are both prime numbers, so I can stop. So now what I want to do is let's look at what numbers they have in common. So I see a 2 over here. Do I see a 2 over here? I do, and because it's common, I'm going to write it on the side. Okay, I see another 2. Do I see another 2? I definitely do. So I'm going to write it on the side. And then what else do I see in common? I see this 3, and I see this 3. So I'm going to write that on the side. So that was step B, find out which primes are common. Step C is multiply them together. So I'm going to put some multiply by signs in between. 2 times 2 times 3 is 12. So the GCF is 12. Okay, now let's look at how we use this. And in order to do it, I am going to clear my screen. Let me click this, and let me click clear layer. And I'll shut this down. Okay, and so let's look at how to factor a monomial from a polynomial. So how are we going to do it? We're going to use that GCF. But let's see how we do it. So step number 1, you're going to find the GCF for all the terms that you're working with. Okay, then what do? Step number 2, you're going to write everything as a product of the GCF and another factor and then step number 3, you're going to pull out the GCF and leave everything else behind. And when we leave it behind, we're going to leave it in parentheses. So pull out the GCF and leave everything else behind. And this is going to make more sense when we look at an example. So let's do an example together. And the example that I want to do is this one. Let's do factor through 3x cubed plus x squared plus 9x squared y. Okay, so the first thing that I need to do is to find the GCF. So I'm going to do some trees. I'm going to write my three terms here, 3x cubed, and then I have an x squared, and then I have a 9x squared y. I'm going to factor these. So 3 is a prime number. I just have a 3 and a 1. And then when I break down x cubed, I have an x, and an x. X squared, I just have an x and an x. And then 9y, 9 can be multiplied 3 and 3. I have an x and an x, and a y is just a y. So now I'm going to look for the terms that I have in common. So I have a 3 here, but I don't have a 3 here, so it's not in common. I have 1x here. I definitely have 1x here, and I have 1x here, so I'm going to write that to the side. And then I have a 1x here, and I have a 1x here, and I have another one here. So I'm going to write that to the side, and I know I'm going to end up multiplying them. I have another x over here, but none here, so I need to stop. So then I'm going to multiply these together. So my GCF is x squared. So what does that mean? Well, let's move on to step 2, which says write everything as a product of the GCF and another factor. So I'm going to take my x squared, and then I'm going to set up some parentheses and think, okay, what do I need to multiply x squared by to get 3x cubed? Well, I definitely need to multiply by 3, and I know I need one more x in order to get it to a cubed. So in parentheses, I have a 3x. Okay, I'm going to put in my plus sign and pull out my x squared. What do I need to multiply x squared by to get x squared? Well, I need a 1. Put in my plus sign, write my x squared. What do I need to multiply x squared by to get 9x squared y? Well, I definitely need that 9. The x squared's already there, so then I need my y. Okay, now let's do step 3. Pull out the GCF and leave everything else behind. So we have our x squared. I'm going to set up my parentheses and leave everything behind. So I have my 3x, I have my plus 1, and I have my plus 9y. And that is what this problem looks like when it's factored. So this is my final answer. If you have any questions, send me an email. Otherwise, have a wonderful day.